Hello and welcome back to another data structure series video. And today's video, I'm going to share about quick short algorithm. So please don't skip this video. Just keep watching. I hope you can understand very well. So what is quick sort? It actually a divide and conquer algorithm, and you need to pick a pivot element, and then you need to partitions array around the pivot, and then you need to recursively sort the partitions, and then the first average case is actually the sort. So how it works? You need to choose a pivot element. So that is the most crucial part of a quick sort, and then you need to partition elements, and how you can do the partitions. You need to compare the elements from left and right with pivot. So you need to compare whether the pivot is like the whether the pivot is greater than the left, and like the pivot should go left if it is greater than, and if it is less than, then it is actually go right. And pivot is now in the final position, and then recursively sort left and right partitions, and then the array will be sorted. So I think probably now still you have some confusions like how it actually works. So let's have some visual overview like how it actually works. So here you can see there is an array, and this is actually an unsorted array, which is 837 on 5, and you need to choose a pivot. So actually here in this example, I chose the last element as a pivot, but the best case is you need to choose it randomly, that then you can get the best result. And someone might choose the first element, so instead of choosing first or last, it would be nice if you can choose randomly. So let's say here I choose the last element as a pivot, and then on the second step, actually we need to compare about the left, like we need to compare the pivot with the left element, I mean the most left element, which is 8. So we compare whether 8 is greater than 5. So 8 is greater than 5, so we don't need to solve. And what we found that 3 is less than 5, so we need to swap to left. I mean, as 3 is less than 5, so 3 should go to the left. So we swap 3 with 8, and 8 now goes to the position of 3, and 3 goes to the position of 8. So 3 8, so they are now swapped. And then like 7 is greater than 5, so there is no swap needed for 7. And then we found that 1 is less than 5, so 1 is to be swapped to left. So why 1 is not position on number at first element? Because like it's already there, so we need to compare with 8. So it like the 1 will go to that position in number 8. And then actually 5 will place on that correct positions. And then we have two partitions, one is 3 on and another is 7 8. And then it actually recursively sort left and right. So let's recursively sort the left partition. So now we can see 3 1 is unsorted, so 1 should go to the left, and 3 should goes to the right, obviously. So now the left partition is sorted, and on the right partition it already sorted like 7 8. And now if we just merge it together, and then it will be sorted. So now it's time for you to implement that sorting in either Python or in JavaScript. And then let's talk about the time and space complexity. So on the best case, like if you choose good pivot, then the time complexity will be big O n log n. And if you choose pivot randomly, then the average time complexity is big O and log n. And if you choose bad pivot or already sorted, then the worst case might happen, like big O n square. Well, and whatever the space complexity is big O log n, and it's not a stable sort because can change equal elements order. Well, so when to use quick sort, it's actually perfect for general purpose sorting, large arrays, and in place sorting needed, and random or unsorted data. So when you should avoid the quick sort, like when it's already sorted arrays and when stability is required, and linked list. So for linked list, I mean merge sort is best, and you need to use randomized pivot to avoid the worst case. Well, and thanks for watching. And now I believe you understand the quick shot. And if you like this video, then don't forget to subscribe and see you on next video. Till then, good luck. Bye bye.